In the first episode of this three-part series, examining electric plasma discharge, we presented the classic Volt-Ampere characteristic plot of a typical laboratory plasma discharge. Then, for the second episode, the solar atmosphere versus laboratory plasma, we discussed how the current density in the actual solar plasma varies with radial distance out from the sun. For reference, here are those two important plots again. Those first two episodes set the stage for us to now complete our virtual journey that started just below the visible surface of the sun's photosphere and then went outward from there. We got out to about as far as Earth's orbit. Now here in the third and concluding episode, we'll complete this virtual journey, but since the distance we have just covered is almost the same territory as NASA's Parker Solar Probe is now exploring, let me mention what I suspect we're going to hear as the Parker probe reports what it finds back to us here on Earth. One of NASA's most spectacular projects has been the Parker Solar Probe, which is presently on its way to approaching the sun in 2025, closer than any manufactured object ever has. Like so many of their earlier projects, the successful designing, engineering, construction, launching, and guiding of this probe has been something of which NASA can be immensely proud. But typically, their descriptions and interpretations of the observations and data they deliver back to us, the public, not so much. For example, a few months ago, NASA press release said that the Parker probe had already touched the sun. They also claimed that the Parker probe will help solve the mysterious questions of where and how the solar wind is formed and why it accelerates as it gets farther away from the sun, and also why the lower corona is unbelievably much hotter than the photosphere, which is closer into the sun's center. But given how far away the Parker probe's planned closest approach will be from the locations where those phenomena take place, it's not likely that the probe will learn very much about the real solar plasma that NASA still unfortunately calls hot gas. What the public usually gets from NASA is exemplified by this figure. The Alphean critical surface boundary - end of solar atmosphere and beginning of solar wind may have been named for Hannes Alphen in his honor, but in reality, there is no such boundary. The solar wind, actually a flow of electrically charged particles, not a wind, begins when it leaves from the photosphere and becomes an integral part of the sun's outer atmosphere, its plasma, all the way out to its farthest extent. The Parker probe's closest approach of 8.86 solar radii is not at all close enough to the sun's photosphere to make any significant measurements of the phenomena in which they claim to be interested. Unless they can maneuver the probe much closer to the photosphere without melting it, not much of anything about the real process of solar wind production and its unexplained acceleration will be revealed by the Parker probe. They're looking in the wrong places. If the probe's trajectory does intersect a Birkeland current or two, it will undoubtedly report enigmatic multiple reversals of the magnetic field. How will NASA explain that if it occurs? Anyway, back to our virtual journey. How far do we have to go? Where does the solar atmosphere really end? The answer to that is out at the heliopause. Now, the heliopause is the outer boundary of our solar system's plasma. It's located at a distance from the sun of about 123 astronomical units. Now, an astronomical unit is the average distance from the sun to the Earth. So 123 astronomical units is 123 times the distance of the sun to the Earth, and it's also 2.5 times the maximum outward distance from the sun that Pluto ever gets to. The plasma that surrounds the solar system, our sun, the planets, and everything else that accompanies these bodies, is different from the plasma of interstellar space. Not in what kinds of charge carriers are present, but in their density and speed. Just inside the heliopause, the density of positive ions and electrons is estimated to be only 10% of the density of those same charge-carrying particles just beyond the heliopause in interstellar space. But the average velocities of the ones inside are 10 times greater. There are fewer of them, but they're going a lot faster. NASA has said the boundary between the solar wind and the interstellar wind is the heliopause. That's right. And then they go on to say that's where the pressure of the two winds are in balance. This balance in pressure causes the solar wind to turn back and flow down the tail of the heliosphere. Now notice there's no mention here of any electrical phenomenon at all, even though the wind consists mostly of positive ions and electrons. NASA only talks about hydraulics, the physics of gases and fluids, winds and pressures, not plasma, not anything electrical, and certainly no mention of what creates that solar wind and why it exists or what it's made of. We submit that our Volt-Ampere plot provides a simpler and more accurate insight into what's actually happening out there at the heliopause. As we move farther out from the sun, beyond even the greatest distance to which Birkeland currents extend, we move out into regions on the extreme left of both the two important figures. This is dark mode territory, points D, C, B, and A on the Volt-Ampere plot. We must remember that the E field, the electric field, is the gradient of the voltage. In other words, the value, the height of this E field curve at any point plotted in the figure represents not its height, not its magnitude, its slope. This E field magnitude is always positive. It never dips below the horizontal axis. That means that moving toward the left, going farther away from the sun, we see a continuous downhill descent of the plasma's voltage. For example, going from F to D, the value of the voltage doesn't get any higher. Its downward slope gets higher valued, gets steeper and steeper. Approaching the heliopause, the E field's maximum downward slope occurs at point D. Now, going from D to C, the voltage itself still maintains its unbroken descent, but its plot versus radial distance is getting less steep. The large E field drop between C and B doesn't mean that the magnitude of the plasma voltage decreases much at all. What it means is that the angle of the descent of that voltage plot is very quickly becoming almost horizontal. And at point A, it's zero, it's flat, it is horizontal. Since the electric field is also a measurement of the force experienced by each positive charge, the electric field's plot taking this final, almost vertical plunge means that the strength of the outward force on the plasma's positive ions is rapidly decreasing, approaching its final value of zero. The fact this electric force has always been positive outward during our journey means the force on positive ions has always been directed outward. That force now ceases to exist, and so does any influence the sun might have beyond point A. From that location, looking back at the sun, it would appear to be an extremely bright star, a single point source, not a disk. That's what stops the solar wind, the electrical force that pushes it. The outwardly directed electric field force shuts off. It has nothing to do with pressure gradients. Electric forces are 10 to the 36 times greater than gas pressure gradients. Incidentally, there's an additional insight the plasma Volt-Ampere plot offers us, just as we're ready to leave the heliopause on this journey out from the sun. Note that points E to D on that plot define the region where the electric field force on positive ions is as strong as it ever gets anywhere on the sun. This strong outward electric field is exactly what the phenomenon called the Townsend discharge requires. The strong E field not only strips electrons from neutral atoms, ionizing them, but also increases their outward velocity. When these positive ions collide with electrons just outside the heliopause, recombination occurs, and that emits light. This weak visual phenomenon is probably what we recently saw in the NASA Lockheed Martin IBEX mission that confirmed the creation, via observation of these recombinations, of energetic neutral atoms, so-called ENAs, right there, in exactly this location. Astrophysicists who still cling to their standard thermonuclear model, in which nuclear fusion supposedly occurs only at the center of the sun, used to worry about the fact that such a reaction must create a strong stream of electron neutrinos that can be measured here on Earth. And although some of those elusive electron neutrino particles have indeed been observed, They apparently have nowhere near the flow density they should have if that standard fusion hypothesis is valid. Over a period of time, experiments consistently observed only about 1/3 the number of neutrinos, electron neutrinos, expected by the standard solar model. But their concern suddenly disappeared after they jubilantly announced their discovery that the missing neutrinos were not actually missing. They had just changed their flavor into other types of neutrinos as they streamed toward Earth. A few recent Earth-bound investigations have reported that the other two types of neutrinos, mu type and tau type, can indeed turn into electron neutrinos. But no experimental results of which this author is aware have ever reported that electron neutrinos, the type that's missing, have ever been observed turning into anything else. So all their subsequent experiments have actually demonstrated, if anything, that there may be too many electron neutrinos showing up here at Earth, not too few. Their missing electron neutrino problem has still not been resolved. They just smilingly ignore this fact. The existence of even a weak neutrino stream, however, did suggest the likelihood of some kind of fusion mechanism taking place somewhere on the sun. So when Wal Thornhill announced that the magnitude of this weak flow seemed to vary with changes in the solar wind flux, the attention, at least of electric universe investigators, became focused on the photosphere as a possible fusion site, because that's where the solar wind comes from. But could plasma somewhere near or within the photosphere have the ability to put the squeeze on atoms strongly enough to cause fusion, transmutation of elements to occur? As we saw earlier, the photosphere lower corona transition, also the chromosphere, is the site, see point H in that figure, of the strongest double layer on the sun. And just to the right of that point, the steeply negative slope of the Volt-Ampere plot suggests the probability of filamentation in the upper photosphere. We know this occurs because we can see it. Each of those filaments carries a current which creates its own local magnetic field. But inside the bundle, those internal fields cancel each other out and sum to form a single strong field encircling the perimeter of the bundle of filaments. The vector calculus description of this electrical mechanism is called Stokes' theorem. The red dots in the figure are filamented electrical currents directed into the page. Note the double layer in the first left-hand image in this figure. The stronger the value of the current density within the bundle of filaments, the stronger that bundle squeezes together. This is how the rapidly accelerated stream of positive ions falling through the double layer's large voltage drop squeezes the plasma flow laterally so that a dethermalizing effect, which is really the loss of sideways random motion, creates the so-called solar temperature minimum or temperature inversion. This location is where positive ions become accelerated to such high velocities that when they collide with other ions and neutral atoms upon leaving the double layer at the bottom of their voltage drop in the lower corona, an intense turbulence is created. The highly filamented structure of the plasma within the photosphere is thus destroyed as the plasma enters the lower corona. This high level of random motion is measured as being an extremely hot temperature. In fact, it's the highest temperature measured anywhere on or near the sun, thereby solving the astronomer's temperature inversion problem. It's also where the maximum energy density is delivered to the plasma by the sun's electric power input. We can find that specific location where the maximum energy is delivered to the plasma as follows. Each and every point in this figure is uniquely defined by the corresponding values that label the two axes, the electric field in volts per meter on the vertical axis, and current density in amps per square meter on the horizontal axis. At each single point in the plasma, the product of those two quantities is the power density in watts per cubic meter delivered to that location in the plasma. In other words, volts per meter times amps per square meter equals watts per cubic meter, and that is power density. And on this plot, the locus of points for any specific value of power density turns out to plot out as a hyperbola. 3 such examples are shown there on the plot. It reveals that the location of the maximum power density delivered to the plasma by its electrical power input is indeed the major double layer at point H. It's obvious. It sticks up there higher than the highest power density curve. Experimental confirmation of the validity of the prediction that transmutation occurs in the sun's transition layer between the top of the photosphere and the bottom of the lower corona, the chromosphere, came when Sapphire discovered traces of 18 new elements on the face of its anode that had not been there in the chamber until after the experiment was completed. The surface of the anode in the Sapphire experiment is analogous to the top of the photosphere on the actual sun. The general shape of the plasma discharge Volt-Ampere plot has been well known for many, many decades. And the Maxwell Heaviside equations have been known for over 120 years. Why has it taken until now for someone to suggest the process we describe here? Was it because Irving Langmuir only explained the plasma structure we call the plasma double layer in the 1930s, and he was awarded the Nobel Prize for it? Or was it because mainstream astronomers have fought tooth and nail against acknowledging any electrical effects, since Lord Kelvin famously said, "I'd rather use a boy on a pony to send a message than use Maxwell or Marconi's work"? The Sapphire transmutation discovery strongly supports our assertion that fusion of elements does indeed take place on the sun, but on its photospheric surface, not in its deep interior. And this falsifies the standard model. The many instances of one-to-one correspondence between the results of the Sapphire Laboratory's detailed study of their electric sun model and actual observations of the sun made over the years provide strong supporting evidence that long accepted, well-known electrical processes are indeed at work in the plasma on and around the sun. These electrical phenomena provide answers to the flood of so-called enigmatic observations that have mystified and seemingly continue to mystify mainstream astronomers. Allow me to list just some of those questions that they can't answer. 1. Why does the sun's plasma corona even exist in the first place? Can you name one non-electrical process that causes an electrical plasma discharge? 2. How can positive ions and minus electrons coexist in plasma without neutralizing each other? They do, you know. 3. Explain the temperature minimum that is located just above the photosphere. How can that occur? Why does it occur? 4. The temperature maximum, that's 2 million degrees centigrade, that is in the lower corona, above the temperature minimum. How can that happen? What causes this temperature inversion? 5. What causes filamentation? Plasma filaments converging into solar coronal caps and streamers and photospheric granules that come and go. 6. The solar wind increases its velocity the farther away from the sun it gets. What non-electrical mechanism can cause this? 7. The solar wind comes in two different types, the fast solar wind and the slow solar wind. They come from different locations on the sun. How and why? 8. The fast solar wind fluctuates in its density and velocity from time to time. Once it even shut off completely for over a day. How? Why? Number 9. Why is there a ring of energetic neutral atoms, ENAs, around the outside of the heliosphere? What creates it? 10. What creates magnetic fields in space? The Maxwell Heaviside equations state unequivocally that magnetic fields are created only by electric currents or time-varying electric fields. Are there electric currents and variable electric fields in space? If not, where do all the magnetic fields that astronomers like to talk about come from? Every single one of these questions has already been straightforwardly answered by the electric sun hypothesis. This list constitutes a direct challenge to the mainstream astrophysics. They remain ignored and unanswered by the defenders of the gaslight era standard model. All we hear from them is a deafening silence or ad hominem attacks. The emperor eventually recognized he was naked. Will they? In conclusion, for those who still cling to the belief that there may be electricity in space, but it doesn't do anything, it's clear that they have embraced a self-inflicted, perpetual state of antagonistic ignorance about the existence and effects of electricity in space. But great advances are being made in astronomy and astrophysics by investigators who do learn about and make use of the tools and discoveries of experimental plasma science and engineering, not by those who continually talk only about hot gas, bow shocks, black holes, magnetic reconnection, dark matter, dark energy, and neutron stars, all the while rejecting the last 120 years of experimentally verified electric scientific progress. This video has presented examples of the obvious correspondence between many different features of the sun's plasma atmosphere and the identical behavior of plasma in well-instrumented laboratories such as SAPPHIRE. Other than scale, there clearly is no difference between the way plasma acts, changes its mode of operation, creates filaments and double layers in the lab, and most of the observations astronomers have proclaimed to be inexplicable. How many of these inexplicable observations does it take to constitute a falsification? Gaslight-era astrophysics seems to be drowning in inexplicable phenomena. The single most rewarding result of our recent efforts was that announcement by SAPPHIRE of their discovery that the products of transmutation of elements had been discovered on the anode of their lab's electric plasma sun model, and thus by analogy in the double layer that exists between the photosphere and the lower corona of the actual sun. This is exactly where electric universe investigators such as Wal Thornhill had predicted it would be found. Several years ago, Wal wrote, and I quote him, "A correlation between the neutrino count and the solar wind particle flux is expected in the electric model, but is inexplicable in the thermonuclear model. It's just that simple. Nuclear cookery takes place in the photosphere, not in the center of the sun," unquote. And now we have strong experimental evidence he was absolutely correct. A thorough understanding of how and why the atmosphere of our sun is a classic electric plasma discharge is a foundation of the electric universe model of cosmology. It's my hope to have provided such an understanding in this 3-episode series. I'm confident and pleased to once again assert and confirm that indeed our sun is electric.